Example 1 we could have done, or we did do without our calculator. Example 2 is an example of a question that is a calculator question. They look similar to start with, but if we're solving for this and we see an equation with cos, so we want to get cos by itself, so I'm going to add 4 to both sides and subtract cos on both sides. So I can add 4, that gives me negative 2 on the left. I'm going to subtract cos, so I'm combining my like terms, and I've got negative 2 equals 3 cos x, dividing both sides by 3 to get cos by itself, and I'm going to get cos x is equal to negative 2 over 3. Now 2/3 is not on our unit circle. It's not a value that we know, so this makes this a calculator question. So we go to our calculator. We're going to need to find our reference angle. Notice that our question is in radians, so when we go to our calculator, we're going to make sure that our mode is in radians, which it is. And so we're going to find our reference angle by doing cos inverse of positive 2/3. 0.841. So remember, to find our reference angle, it's always the inverse of the positive values. 0.841 to find our reference angle. Now, cos is negative in quadrants 2 and 3. So you can draw a picture if you're still, eventually you're going to get to the point where you have the pictures in your head and you just do the math. But until that point, you're going to draw your picture, you're going to label your reference angle, and the picture really helps you see what you need to do. So if I want to solve for x, in quadrant 2, can you see that you would do pi minus your reference angle? And in quadrant 3, you would do pi plus your reference angle. So I'm going to go back to my calculator. I'm going to store, above your on button, hit the store button. I'm going to store my reference angle as x, just so that I can do math a little bit easier. So pi minus my reference angle, that's in quadrant 2. And pi plus my reference angle, that's my answer in quadrant 3. So I get 2.3 and 3.98. Now notice what I did. I solved between 0 and 2 pi because you sort of get into a groove. You start solving a question, you're so used to solving between 0 and 2 pi, that's what you do. But now we look and say, what is the actual domain that they asked for? They asked for negative pi over 2 to 3 pi over 2. So what does that mean? That means we're looking for all answers between 0 and negative pi over 2. Does that make sense that I'm looking for these negative answers, 0 to, and these positive answers? So our answers are right. We don't have to change anything because our positive answers are going to hit, we're going to hit quadrant 2 and quadrant 3. And from our diagrams, can you see that we had no answers in quadrant 4? So we end up with no negative answers. But we did have to think about the domain and see what kind of answers we would get. And then to write, oh, it says to the nearest hundredth, so I guess I have to add 2.30, was that? Yeah. Okay, good. So that would be correct to the nearest hundredth, having to add that extra 0. Notice a couple of things about rounding. You will lose marks if your final answer isn't rounded correctly, which means if you had rounded your reference angle early and done your work with a rounded value of 0.8 instead of 0.841, or even what we've done by hitting the store button on our calculator, by hitting that store button on the calculator, we've saved all of the decimal places. And so we know that we're working with exact values until the end, and then when we round our final answer, we know that our rounding will be correct. So there's always a half a mark deduction if you round early, and that rounding early causes your final answer to be off. So now that we've got our two answers here, it says then write the general solution. So remember, how do we find our general solution? Well, if we first solve between 0 and 2 pi, which we have, we can then write both of those answers, 2.30 and 3.98, and add 2k pi to each of them. Where k is an integer. So for the general solution, the only thing different is you take all of your answers from 0 to 2 pi and add 2k pi to them to list every single coterminal angle with 2.3 and 3.98. Now for part B, is everybody done? Yes? For part B, to the nearest degree, solve the equation root 2 cosecant x equals -5. So it's a cosecant question. I can get cosecant by itself by dividing both sides by root 2. How do we solve cosecant questions? Well, the answers for cosecant x equals -5 over root 2 will be the same as the answers for sine of x, where we do the reciprocal. Again, how do we solve a sine equation? That's not on our unit circle. We're going to have to go to our calculator. We're going to go to our calculator and find the inverse. And root 2 over 5. Oh, is this one in degrees? Thank you. So before I enter anything, I hit my mode button. Yes, always checking. Okay, let's say I have it in radians. I want to show you something that you can do. Let's say you do it in radians and you do sine inverse of, because this is most likely what would happen, root 2 divided by 5. Again, it's the positive values here. You get 0.286, and at this moment you realize, oh shoot, I wanted to find my reference angle, and I was supposed to be in radians. So you go back to your calculator, you think, I've got to retype everything, I go to my mode, change it to degrees. But instead of retyping it, you can just go either and highlight and push enter again. And now it'll put the answer in degrees. If you have an older calculator, you can go second, enter, and it always retypes what you had typed before. Push enter, and now it's in degrees, 16.4 degrees. So our reference angle is 16.4 degrees. Since sine is negative, what quadrants would we be looking in? Quadrant 3 and quadrant 4. So here is our reference angle. And again, once you see, if you have this picture, either you're drawing this picture or this picture's in your head, can you see that one answer will be 180 degrees plus your reference angle, and the other one 360 degrees minus your reference angle? So when I go to write these answers out, again, I'm going to store my reference angle as x, and I can go 180 plus x for quadrant 3, and 360 minus x for, 360 minus x for quadrant 4. So I know 196.4 and 343.5 says to the nearest degree. So I just need 196 and 344. And again, that's solving between 0 and 360 degrees. What was our actual domain? From negative 180 to 180. So if I think about that, from negative 180 to 180, that would mean negative angles from 0 to negative 180, and positive angles from 0 to 180. Our two answers in quadrant 3 and quadrant 4, we would now have to rewrite them as negative angles. Since our reference angle is 16 degrees, can you see that this one in quadrant 4 would be negative 16 degrees? And the one in quadrant 3 would be 180 minus 16 degrees, 164 degrees negative. So we had our two answers between 0 and 360, but then we would had to relook at the domain and find out what would be coterminal with those ones to make it work. Okay? Another way that you could get them to be coterminal is if you had figured out 344. Can you see that if you subtracted 360 degrees off of 344, you get minus 16? And if you took 196 and subtracted 360 degrees, you would get negative 164. So there's another way you can figure out which ones are going to be coterminal. Again, coterminal angles, you can add or subtract 360 degrees as many times as you'd like. And you can do that until you get answers in the domain that you're looking for. Did this one say write the general solution? Yes, it did. So your general solution, we take our two answers between 0 and 360 degrees. And write all the coterminal angles with those. Question. If I had written this, would it be wrong? If I'd written the green, would it be wrong? No. So sometimes if you read the textbook examples, they just use whatever final answers they got and did coterminal. But since negative 16 is coterminal with 344, those are the same. And since negative 164 is coterminal with 196, those are the same. It doesn't matter which starting point you use and have all the coterminal ones with it, because it will be the same. But as a nice, we've sort of developed a technique and a system for how do I write the general solution. I solve between 0 and 360 first, and then add 360 times k. So the blue one is the nice one that sort of follows that. But it's, if you read your textbook, sometimes your textbook has the other coterminal angles. And if you feel like, did I do something wrong? No. It's just a recognition that those are the same answers. Okay, so for questions on this one, questions 6 and 7,